Hi, my name is Zhihao Yu. Today, I'm going to talk about the project of Georgia Tech ECE 4180 for 2020 project called the Smart Home Cube. At the very beginning of the project proposal stage, I was thinking of making a custom-built IoT device, considering my personal interests and knowledge base in smart home. The project idea skeleton was inspired by smart home manufacturer Acura's product called Cube, which is a small device capable of triggering smart home commands with 6 different gestures, including shake and rotate. Thus, I came up with my own idea of building a cube-shaped smart home IoT device capable of various functions and compatible to open-source smart home standards. The project is realized with a Mbed LPC1768 board and a ESP32 board as the controllers. The Smart Home Service is a home assistant running on my own home Linux server with a MQTT server integrated. The Mbed board is loaded with code to interfacing with all the input and output devices on the cube and communicate with the ESP32 board through UART interface. The ESP32 board is loaded with ESP Home firmware to provide necessary network services like SNTP to the Mbed board through UART, and also to interact with Home Assistant Smart Home Server through native API over Wi-Fi or MQTT service relayed by the MQTT server. Functionality-wise, the device is capable of display year, date, and time on the LCD screen with time put from SNTP service. The video here shows how such function works. Also, when there's new notification in the smart home system, the RGB LED on the cube will be lit to show as the reminder, and the color can be controlled by notification type. As you can see in the video, when a new notification appears in the smart home system, the notification LED will turn on with purple color. And after the vibration is detected with a gentle knock, the notification will be dismissed and the LED will be turned off. More than that, the Cube is capable of control up to 4 smart home switch type devices with state indicator LEDs. As seen in the video, after the orientation being detected to change to left, it enters the smart home device control mode. Pushing the corresponding momentum switch will toggle the device as well as toggle the status indicating LED on the device. The design of the cube are 6 panels that are fabricated independently and then can be assembled together, as the CAD model and graphic rendering shown in the slide. First of all, the front panel has a square opening to fit in the ULCD screen and a run-through hole to mount the RGB LED, while it just looks like above after assembled. The wiring for the front panel has 2 connectors for the LCD screen and RGB LED respectively. The 2 power pins 5V and ground and 3 data pins TXRX and reset of the LCD screen are directly fed to the 5-pin connector, while the 3 anodes of the RGB LED are connected to 3 resistors in series with resistance values according to the manual and then together with the common cathode fed to the 4-pin connector. The back panel is designed to fit up to 4 18650 batteries and left with 3 openings for a micro USB port for charging, a Type A USB port for powering, and a toggle switch as the power switch for the device. The wiring for the back panel is straightforward with 4 batteries connected with each 2 in series and 2 pairs in parallel, and a BMS board is connected to provide protection as well as charging and powering capabilities. The 5V power output from the batteries through BMS are fed to the 2-pin power connector. The left panel have 4 through holes with clamping mechanism to mount and secure the 4 momentum switches, and 4 half-through holes for LEDs to be mounted and to be seen from the other side. 4 pull-up resistors are connected in series with the anodes of the LEDs and the other end to the 2 5-pin I/O connectors, while the cathodes of the LEDs are grounded together and fed to the ground pin on the connector. The 4 momentum switches are wired in the same way, only with the pull-up resistor on the main control board, which is the other side of the connectors. The bottom panel comes with ridges on the outside to secure the other panels in shape and position, while a small hole is put in the middle to easily access the reset button of the BMS. The right and top panels are currently just plain structure panels, but can be modified in future to mount different devices for further functionalities. Finally is the hidden control board with the 2 controllers and the IMU. Most wirings and mapping are done on this board, while the connectors are utilized to easily attach and detach the electrical connection between the board and the panels. Next, it's the coding part. First comes the Mbed Code and its included libraries, which are the basic and RTOS libraries, as well as the 2 device libraries for LCD and IMU. Pi is also defined as a constant for post calculation. Then the IOs are defined and the ports are mapped. Mutexes are declared to resolve RTOS multi-threading potential conflicts, and global variables are defined to be used across threads. In the main function before while loop, Bootup initiation operations are conducted, including initialize the UART interface, startup and clear LCD screen, reset all LEDs, and startup and calibrate IMU. Also, global variables are given their initial values, while RTOS threads are declared and started. The main function while loop is also the UART transceiver thread. UART data are reading byte by byte, being decoded and stored into 2 separate char arrays called command and payload for further operations by calling the execute self-defined function, which executes the command and stores the payload. The pulse and vibration processing thread reads in gyroscope and accelerometer values from the LSM90S1 IMU, then calculates pulse and pitch, and eventually updates global variables for detected orientation change and vibration. The thread reacts differently at different orientations. At orientation with left panel facing up, the thread asks for smart home device status through UART and toggle devices once corresponding momentum switch being pressed. The thread right now do nothing at other orientations, but further development can add other orientation related functions to it easily.